Hello, online students and anybody who decided they needed another review of rational expressions. So rational expressions, if you look at the word rational, you can see the word ratio, and ratio means fraction. So we're talking about algebraic expressions with letters and numbers and plus and minus and division and multiplication put into a fraction form. So actually the division is the fraction. So what we're going to be looking at today is what to do when you have two rational expressions that need to be multiplied together, or a rational expression that's a fraction that needs to be reduced or simplified. Sometimes you'll come across rational expressions, algebraic fractions, that can't be reduced at all. Like this, x plus 3 over x. Now you might be tempted to think that you can actually reduce the x's there, but you can't. Remember, think of x was a number. If you had 7 plus 3, if x stands for 7, and you had 7 plus 3 over 7, you couldn't reduce the 7's because that's 10 over 7, and 10 over 7 doesn't reduce at all. So you can't reduce if there's a plus or a minus in between the parts that you're trying to reduce. So you can't reduce the x's here and here. That one is unreducible. It's an unsimplifiable fraction. Now, on the other hand, if you get a rational expression that can be reduced, you're going to recognize it because you're going to be able to factor one of the parts and possibly get it to look like the other part. So let's see. I should have crossed this one out because you can't do that. That's not right. All right, so this next one, if I look at the top of this fraction, I see that I've got x squared plus 3x. I can factor out an x. That's going to leave me with x plus 3. And now I have x times x plus 3 over another factor of x plus 3. That's like having 10 over 2. The reason you can reduce that is because 10 can be factored into 2 times 5, and then you can reduce the 2's. Once you have multiplication, you can reduce, but you can't do it with addition or subtraction. So now that we've turned this into a multiplication, we can reduce the two factors on top and bottom because x plus 3 over x plus 3 equals 1, and so we're left with just x. Okay, here's another more complicated one. What if you had a trinomial on top? Well, if you can get it to factor, you might be able to reduce something on the top with that x plus 3 on the bottom. So those factoring skills, they're never going to go away. You're going to need them all the way through math. It's one of those basic skills like adding and subtracting that you have to be able to do. So x squared plus 2x plus 3, I think that factors into x plus 3 times x minus 1. So we can reduce it, x plus 3 and x plus 3, and we reduce that to x plus 1. Or did I say minus 1? Minus 1. My mistake on that. Okay, another one. What if you had the factorable expression in the denominator? That also might simplify for you. Let's see. We'll leave x plus 4 as it is. Put on your factoring hat. X squared minus 5x plus 4. That's going to be x minus 4, x minus 1. Oh, so close. But unfortunately, the x plus 4 and the x minus 4 represent different numbers, not necessarily reducible. So we cannot reduce them. So we say does not simplify. You just leave it as it is. Okay, let's try another one. How about something like this? Okay, very tempting to go, oh, I see a lot of canceling. I could go x cancels with x. I could go this x cancels with this x. But you can't do it because those are added and to another term. So first you have to factor it, then you can think about reducing it. The top part has a GCF of x. Divide out or factor out that x. The bottom also has a GCF of x, leaving with x squared plus 5. Now, does x squared plus 5 factor any further? It's a sum, but it doesn't factor. So the only thing I see that reduces is this factor of x in the front. X over x equals 1, leaving me with x plus 3 over x squared plus 5. All right, sometimes you get a numerical GCF, like for example in this one. Okay, I see that the numerator, the top of the fraction, has a common factor of 5 between the two terms. And then 10x in the bottom, if you want to, think of it as being 5 times 2x. I did that because I knew I wanted to get that to reduce. So the 5 and the 5 reduce, leaving me with x plus 6 over 2x. And no, I can't reduce these x's because the top one is attached to the 6 with a plus, and the bottom was attached to a 2 with multiplication. All right, here's one of my favorites. Good old difference of two squares. Okay. This one, I'm going to play a little complicated trick on you. Let's see what you think about this. Okay, the denominator's already factored. That's nice. It's ready to go. It looks a little weird because the second and the third factor in the denominator are kind of backwards of how we usually write them. We usually put the x first, but that's okay. Let me see. The top is a difference of two squares. Remember how that factors so nicely into x plus 2, x minus 2? X squared minus 4, that's a difference of two squares that I'm talking about right here, factors into x plus 2, x minus 2. Work it out, FOIL it out, you'll see that I'm right. Okay, now, this factor, 2 minus x, if I pulled a negative out, that would be x minus 2. So basically I factor out a negative 1. I moved it out in front out here, and that allowed me to reverse the order of the subtraction and make it x minus 2. I really wanted it to cancel with this, so I factored out the negative. And then 2 plus x, the second factor that was originally in the bottom there, in the parentheses, 2 plus x, x plus 2, that's the same thing. So I'm going to go ahead and turn that one around as well. I don't have to factor anything out to turn addition around, and now that cancels. So really the only thing I have left is a negative 1 that I factored out and the x, and they're in the bottom. So what do we do when we have nothing left in the numerator? We put a 1 to hold the place because we did reduce something over something and it reduced to 1. Now some people might write this negative 1 on top over x. The negative can go with either the top or the bottom or even right out in the middle. Those all mean the same thing. All three of those answers are the same thing, negative 1 over x. Okay, so those were just single fractions that needed to be simplified or reduced, and factoring is your tool that you're going to use to do that. Pull out a GCF or do your binomial factorization. Okay, now what if you have two algebraic expressions that you would like to multiply together? Like, for example, this one, x squared minus 9 over 4x, and you want to multiply that times another algebraic rational expression like this one. Okay, it's a fraction times a fraction. The rules for multiplying fractions are you multiply the tops, and then you multiply the bottoms, and then you reduce, or reduce first so that you're working with smaller numbers. So that's what I'm thinking about doing. I'm thinking about factoring as much as I can and hoping, crossing my fingers, that something's going to cancel out. The first fraction's numerator, the top, factors into that nice difference of two squares. 4x is just a single term. I don't think I need to reduce that or factor that. 12x cubed is just a single term. And then in the denominator of the second fraction, I might get lucky and be able to factor that. Yes, x minus 3, x minus 1 is going to give me the correct middle term and a positive 3 on the end. Okay, that's beautiful. I've got a cancellation there. X plus 3 and x minus 1, those don't cancel, but numerically I've got a 12 as a factor and a 4 as a factor. 4 times x. You can think of them as separate. 4 times x. The 4 can reduce with the 12, and one of the x's, this x in the denominator, can reduce with one of the x's in the numerator. So the 12 and the 4 are going to cancel to give me a 3. And then x cubed and the x on the bottom are going to cancel to give me x squared. So what do I have left? I have got an x plus 3. Let's put that over here. I have got a 3, and I've got an x squared. I'm going to put those out in front. That's more the proper way of writing it, is to put that out in front. And then on the bottom, the 4 and the x, those canceled out, but I do still have this x minus 1 right here. So let's not forget that, x minus 1. So I didn't need this big fraction bar here. A smaller one will suffice. And then maybe you're tempted to try to do some more reducing. It's kind of addictive to reduce things and simplify, but we're done because the x in the bottom is connected with a -1. And so we can't reduce it with the x's that we see in the top. Okay, let's try one more of those. Let's try a little bit more complicated one. I know, you can do it. All right, this one, x cubed minus 9x squared plus 20x over x squared minus 4x, and that's being multiplied times another rational expression. Okay, all right, now what? Well, as everything is, all of the terms are connected to other terms with plus and minus. I want to separate them into factors. So I want to factor each one of the parts. So I'm going to start with the numerator of the first fraction. I see a GCF of x. That's going to help in a big way because now I can factor it, I think, yeah, x minus 4 and x minus 5. So I did 2 steps of factoring there to get to where I wanted. Okay, so I don't need this one anymore. In the bottom, I can pull out an x. That leaves me with x minus 4. This is looking good. Second fraction, numerator. Got a GCF of 3. Pull that out. Oops, I forgot to pull it out of that last term there. So it's going to make it x plus 1. Always double kind of check to see if your FOIL would give you back, or your distribution will put you back to where you were. And then let's see, the denominator, factor, x minus 5x plus 1. Okay, now here's the fun part, right? Here's where you get to cancel stuff out. I see an x plus 1 and an x plus 1. I see an x minus 5 on top and x minus 5 on bottom. It has to be on top and bottom, but it doesn't have to be directly above each other. You can go across, too. Ooh, x minus 4, x minus 4. Oh, boy. X and x. We've canceled everything out except for this 3 right here. So our final answer is going to be 3. I like it when that happens. Okay, last 2 examples. What if we need to do, well, one example. What if we need to do a division problem? We just did 2 multiplication problems. We had pretty complicated rational expressions that we needed to multiply together. But what if it was a division problem? We did these last year. It's no big deal. You're going to see it written like this with this old division symbol there. And 2 fractions being divided. What do we do for that? What do you remember? Maybe from elementary school when you learned how to divide fractions. Well, we change division to multiplication, and we flip the second fraction over. So the first fraction stays the same, but the second fraction becomes its reciprocal. So you flip that puppy over. And then you just multiply. And you definitely don't want to multiply this until you've factored it and reduced. I mean, you could multiply it together now, but it would end up this big, long polynomial. So I recommend that you factor first. So I'm going to start with this. That is a difference of 2 squares, everybody. 2x plus 5 and 2x minus 5. It's a little more complicated than your typical difference of 2 squares, but not bad. Bottom of the first fraction, I see a GCF, a 2 and an x. Both of those terms are divisible by 2 and x. So if I factor that out, I think it's x minus 12. Double check. 2x squared minus 24x. Okay, we're good. Okay, second fraction. Looks like a factorable trinomial to me. Let's see. I need 2 numbers that multiply to give me 36 and add to give me negative 9. Multiply to give me negative 36. 6 and 6, 9 and 4. Oh, I got it. 12 and 3. Minus 12 plus 3. Took me a few products to figure out the right one. And then the bottom, that's one of those hard ones. Those are harder to factor, but not too bad because 2x squared can only be 2x times x. And then 16 could be 8 times 2, 4 times 4, 16 times 1. Let's see, if we went 4 and 4, I don't think that's going to work. 8 and 2. 8 and 2. I don't know that that's going to work either. What is it, guys? Is it 4 and 4? Did I write the problem down right? 2x squared minus x. I didn't write the problem down right. My problem was 15 and I wrote 16. You were probably screaming at the video, telling me I wrote it down wrong. Okay, that's better because I wasn't thinking I was going to be able to get this to factor. All right, so to get the minus 15 there, what are we going to do? 8 and 2? 8 and 2, that's going to be 16. 4 and 4, 2 times. Oh, wait, now it's 15, so I have different numbers here. Boy, you guys are probably screaming at me through the video. All right, 15. How about 3 times 5 or 15 times 1? All right, this is going to work now. Let's go with 3 and 5. Took me a minute there. Minus 3 plus 5. Okay, that's going to work. I should have guessed because if I looked over here, I would have seen the 2x plus 5 and the 2x plus 5. Those are going to cancel out. Boom. What else? Oh, x minus 12, x minus 12. And I think that's it. So we're left with a factor of 2x minus 5 on the top, as well as an x plus 3. On the bottom, a 2x and an x minus 3. You do not need to multiply these back out into a polynomial with no parentheses. It's okay to leave it in factor form because very oftentimes in a math problem you're going to use that for something else and you don't want to have to factor it again after you just unfactor it. So that's how you leave it. All right, so you have a worksheet that has just a few of these to practice and then a bunch of review for ACT and of the previous unit. That's how we're going to do it. We're going to cycle back, give you a few new problems, and then cycle back and review. Good luck. Thanks. Bye.